Good morning. This is Mark at the Wicked Edge Expert Corner Group, and we're talking angles and micro adjusters, and why angles and why micro adjusters. Because the Wicked Edge is so good. Let me show you what I have here. I have recreated through parts a Wicked Edge 100 original model that has non-locking adjusters. I have it turned around. As non-locking adjusters, all they do is the ball swivels and it has the hex screw that goes into the divots. And we put it in the divot once we figure out how to pick the screw hole, the little pointy hole that matches the angle we're looking for. I'm trying to put it in 20. I think I got it in there right. Here's the cube that I'm zeroing out, and close enough, 7/100ths for this. We're going to talk about cubes later. And there you go. 20 degrees, it was off 7/100ths. So you can see the rule holds. When the knife edge is clamped 5/8 of an inch above the jawline. That's how it's calibrated. When the knife edge is 5/8 of an inch above the jawline, all that stuff lines up. And to show you that is the case, there's 21 degrees. It floats a little bit. There's a little wobble, little positioning, but okay, now you can see that it's pretty close to exactly where it was. The rule holds. But what happens is if the knife edge is not 5/8 of an inch above the jawline, that jawline, the rule varies. How much it varies, it's hard to say. By lifting up this stone, it's like putting a taller knife. And you can see that it varies. Now we're almost at 20 degrees, but it's a lot of height difference. But there's a lot of different knives. So it works. The rule is true how it's designed. But what happened was these were designed by a guy that was a field outfitter that would use his knives up during the day, field dressing, game, and at night they needed a way to sharpen them. And they came up with this idea, and it worked really well for them, but of course they were sharpening knives that were like 5/8 inch above the jawline. And it worked great, and they wanted to use it for other things, and then they started using more stones, and it got into a very serious line, but the geometry limited it because the rule didn't hold except for 5/8 of an inch. So we started working with the cube. And the cube would show you when you were someplace other than, and what people would say, well, the thing isn't any good because the numbers don't match. Well, the numbers do match. I showed you the numbers match. That's the calibration. But if you want to work outside of the box with a knife that's taller or shorter than the calibration parameters based on the Pythagorean theorem, right triangles, 3 sides inside 180 degrees, you can do anything you want, but it's going to be 180 degrees. So whatever we do to here, to here, to here has to stay the same if we want to put a taller knife on there and work at that same angle. If we want to use the same center line, this same square bar and get that same 15 degrees out of a taller knife. We just suck out that triangle, make it bigger. Well, how do you know that you've done that without working with the cube? So the first thing we had to do was figure out how do we work with the cube when the thing is locked in there in the little divots. Well, what the first micro adjusters were is we simply unscrewed the divot, and it's that little point barely fits in there, and you can hear it chattering. So it takes a bunch of turns to get it seated all the way into that point to get it secure. So that's why I'm turning and turning and turning. It's deep into there. See how it's still locked? And I'm turning and it's still locked. It has a lot of room, but there's room to chatter. So it takes some practice. So we would take it off and turn it around to the other side and then swap it end for end and put it on, so that now the adjuster was screwing against the flat side of the back side of the bar. So now we could slide it anywhere we want with just a little touch. Instead of that all the way in to get it seated into the divot, just that little touch. And if you were knowledgeable, you took that pointed screw and you filed it so it was flat. Because you can see my square bar has dimples on it from using it with this micro adjuster method from the backside. So that's how we made this into a micro adjuster, the fixed position balls on the Wicked Edge 100 with the standard vise and no micro adjusters. Now we turn it around to the back side. And we just slide it as we read it. And then lock that tip of the screw against the back side of the square bar. So that was the first micro adjusters. That let us repurpose, expand the usefulness of the Wicked Edge 100 with the fixed position based on the 5/8 of an inch. Now going and using the flat side and a cube, we could slide it anywhere. So any knife edge, we had control over the length of those sides. We could expand the length of the bottom side. We expanded the length of the top side of the center by putting a taller knife in there. So now we're spreading this to expand the side, and then that keeps this angle the same, the relationship, the Pythagorean theorem. Working with the cube, with the Wicked Edge. So we expanded the usefulness of the Wicked Edge 100. Well, because of this, it's so compact, and we want to use it for more knives, Wicked Edge got bigger and bigger and bigger. The Wicked Edge 120 was this with this riser block put underneath it, and they went to a longer square bar to keep everything proportionate. And that expanded because now you're working with the cube, and we expanded it because we got bigger to accept more variety of knives. It made that triangle big enough to accept more different heights and sizes, and made the triangle bigger because people were working with the cube. And instead of my way, the way that I learned from those before me, to work with the bar turned around to the back, because there were no way of moving that ball in or out. Well, then Wicked Edge introduced the first micro adjusters that added a screw here. So then we went back to putting it on the square bar, and this is an original Wicked Edge 120 bracket from 2015. And the sockets were very large, and now I lock it in to the angle where we were doing it just like the 120, but on the top we have an adjustment. We could either use a wrench or put the Wicked Edge hex tool in here, which I don't see laying here right now. Here it is. Or we would dial in it with the Wicked Edge. You can see the screw turning. And that, with the cube on resting, like I was sliding it, well now Wicked Edge came back at us with the screw. This is as the years went on, they made improvements, they made it bigger. Now that was the Wicked Edge 120. The first ones had a solid, the newer ones had a hollow U to the riser blocks, but they all had the one screw because the standard vise had one screw hole. That's important because the newer standard vise and the dual cam vise, I'm looking to see, do I have a newer standard vise there? The newer standard vise and the dual cam vise all require 2 screws. So we were limited with this space. Another story. Still talking about the micro adjusters. Now we lock it and then we dial it in and lock it up. Well, the original method of locking up the adjusters was to use that set screw, just like we used to put it in the divots. That set screw screwed against the threads of the micro adjuster. And over time it boogered it. If you were like me using whetstones, whetstones are all different thicknesses. If you're like me and you work with whetstones, and then the diamond stones, you might start with diamonds and then switch to whetstones. The thickness is changed, and then go back to strops, again thinner. So we needed to be able to adjust a lot. So this was a problem. And then Wicked Edge moved forward and started using lock screws. This is the newest one that was on a Wicked Edge 130 or 120, and it still has the pin screw that locks on the square bar. And now you loosen the little knurled knob and you use the key and you dial it in. Now everything was reduced, minimized. This is the original one. You see how big it is? This is the newer one. It's been minimized. That's because as the popularity of these grew and people wanted to use it for more knives and more variety of sizes, because of the situation with the angles and the mathematical relationship, Wicked Edge sought to reduce everything shorter, because the shorter you can make this, the lower down the stone is. Right now, how we are with these original large micro adjusters with these big sockets and the Wicked Edge stones on this little vise, it wasn't very efficient because we were limited in how much of the stone we used. We could use the whole stone, but we were turning it over So we were working with the stones, and we would take them and turn them over to distribute the wear because we weren't able to use all of the stone. And we were finding that we were using this big stone and only using a part of it. So we looked to reduce everything to make the stone lower relative to the height of the clamped knife edge. Ideally, you would want to have your stone start level with your knife edge. The risers that Wicked Edge introduced showed me when this got taller, Wicked Edge got wider with the square bar to keep the relationship, but I saw how it got taller next to the stone, how it improved the ability to use the stone. And now we had the micro adjusters, so the two of them together enhance the ability of the Wicked Edge just tenfold. And then the Wicked Edge 130 came out, and it was taller still than the Wicked Edge 120 was. The 120 was the standard vise with the riser. Well, now the Wicked Edge 130 came out, and it was taller still with the wider square bar. So now it was game on. Now the angle, you say, but the angle doesn't change. You know, but yeah, it changes because you got bigger, so the angle doesn't change. What changes is the internal size of the triangle. The triangle still is 180 degrees. We're still making that 15-degree angle, but we had to go wider because we got taller. It's still the same triangle, but we have more space. So with the micro adjusters and more space and a cube, you can really dial it in. And now because I'm using a riser block, that's what led me to work with a 100th of a degree cube, because everything is perfect for the precision. Because it's big. Now we have the Wicked Edge 130. I took that and put it on top of a riser, made it even bigger, made a bigger square bar, everything, but still 3 sides add up to 180 degrees. I'm beating it to death, but it's a hard concept to understand. If I asked you to move the hands, the second hands of a lady's wristwatch, or I asked you to move the hands of second hands of a school wall clock. See what I'm saying? One is so tiny, but it's the same time. It's the same unit. So we expanded it, and now with working with this, with the micro adjusters, we were able to really dial it in. And then when we start to pay attention to our clamping position, so that we are repeatedly using that same clamping position with that precision that we've learned to use working with the Wicked Edge as it gets bigger. It lets you dial it in. And that sharpness we saw with the field dress knives, with the Wicked Edge 100, now with all that stuff, our efforts are controlled to that place because we clamp it, because we use the micro. We do all those different things. Why do we do that? We do them because we want to make the sharpest knife, because it makes me feel good that I'm sharpening that knife, that when I use it the way it feels, it just puts a smile on my face. That's why I do it. It's subjective. It's how I feel with the knife. And by working at this level with the cubes, dialing everything in so that when I say it's 15 degrees, it's 15 degrees, that allows me to compare, to make a judgment. You can't get faster in a race without practicing with a stopwatch. You can't get better at sharpening knives without making a standard for yourself. The position and the angle. And if you're not referencing your position and angle to something that you can count on and you enjoy working with, that you feel comfortable with, then how are you ever going to improve? Because if you clamp it this way one time, you clamp it this way another time. Listen, if you change more than one thing, then how do you know what you did that made the difference? It's that simple. So we're trying to lock everything up. I'm locking everything up and measuring that angle as precisely as I can. So that's my standard. And then the rest now is on me and my sharpening craft and my thought and trying to find that perfect edge for myself. See, now because I'm doing everything the same, then those things that I do matter because I've pinpointed the change. I don't have all this other stuff. That's why the precision. That's why I work with that precision, so I can study the edge leading and the angle and compare it to one angle as compared to the other, because I have a bunch of knives that are all the same and all different steels, so I can compare steel. If I didn't standardize everything, I don't know how I could make a intelligible statement and come to a conclusion or a judgment about anything, because sharpening is so subjective. So that's why I work at this level of precision. Do you need to work at that level of precision to sharpen well? Absolutely not. All you need to do is put a keen edge on both sides and have them come to a keen apex, and your knife, and that person might be sharpening better than me with all this stuff and rigmarole and precision and dialing it in and high boys and tall boys, stabilizers, all that. That person might still be freehand sharpening better than me, and that's fine. But this is my toy and what I choose, my tool, my toy that I choose to work with, because I enjoy the process. It's a labor of love for me. But at the same time, if you're working at that level of precision, you're polishing steel and you are working with a precision machine. So what I'm doing is really practical and scientific. What you do with it is up to you. You don't have to think that because you're not working to 100th of a degree and your knife that you just spent, your M390 Spyderco that you put 15 degrees on, 15.00 degrees on it, and it's not what you expected. It's not because of this. The precision isn't going to matter. If it was turned out that, you screwed up and you put a 16-degree edge on it, you meant to do a 15. It didn't screw up that knife because the angle wasn't right. The precision, it's not like the answer. It's not, A, B, C, or D. If you don't work precise A, you got it wrong. It's not the angle doesn't matter as long as it's keen. We work at that angle because we choose to. And because there are certain rules that correlate over time and experience the hardness of the steel with the edge rolling as compared to the edge breaking down as compared to the edge chipping out. Harder steels are more brittle, they chip out. Softer steels roll. So the hardness of the steel and the durability has something to do with the angle, because a softer steel can't handle the stress that it can with a wider angle because it's got more soft steel behind it to support the edge. A harder steel can support a narrower edge before it breaks or damages. So the harder steels we can make thinner, and the angle thinner, we correlate them with sharper because it's thinner. It comes together with the micro adjusters, with the angle, with the knives, with the steel. Everything works together. I'm going to stop here because I need to talk about cubes and I need to talk about micro adjusters. I'm going to review this, see if I made it understood. Thank you.